We'll now go over the print settings that you need to be aware of in order to get a successful engraving or cut from the laser cutter. I'll briefly go over each section and highlight the important settings you need to be aware of. We'll start with resolution. Now, resolution refers to only when you're engraving, and you have the option to set this between 100 dpi or 1000 dpi. The important thing to know here is that the higher the number, the higher the resolution, but it's also going to mean a longer engraving time. It's also important to note that the quality of the artwork being sent to the laser is going to have a much bigger influence on the look of the final product than the resolution. So what I mean here is you want to start with a high quality image. If you download a low resolution image, you can crank up the resolution all you want. It's really not going to improve the quality. Here's a quick cheat sheet to use to know what resolution to use, and this will be posted next to the laser as well. For most things, you'll be fine at keeping it at the default resolution of 500 dpi. This is a great compromise which gets you good quality at a relatively good speed. 1 to 200 dpi, you're looking at draft runs, you have an idea and you just want to see how it'll look before you commit to it, and so you really want to get it out quickly. This is also a good resolution to use when you don't want to remove too much material, for example when you're engraving fabric. At around 250 dpi is useful for materials such as glass, marble, and plastic because these items don't really benefit from a high dpi. 4 to 500 dpi is pretty much the sweet spot that's going to give you a good compromise for really good quality and fast speeds. So what I would recommend is just keeping everything at 500 dpi unless you have a specific need to change the resolution. Now at 1000 dpi, this is your highest possible resolution, and you would use this if you're, for example, engraving really small fonts and you need them to show up clearly. This resolution is seldom used because most people really can't discern the difference between something engraved at 1000 dpi and 500 dpi. And at 500 dpi, you're going to be able to engrave it 2 times faster. Here you get to choose between raster, which is engraving, vector, which is cutting, or combined when you're doing both rastering and vectoring. Below that, you'll see your piece size. This is where you're going to set the size of your cutting area. Now, what we normally do is we just set this to the size of the laser bed, which is 16 inches horizontal and 12 inches vertical. The important thing here is that whatever you set this to, it needs to match the artboard in Illustrator. Okay, next let's talk about speed, power, and frequency. And you'll see that within your raster settings, you have the option to set your speed and power. And within your vector settings, you can set your speed, power, and frequency. Now, speed refers to the travel speed of the laser carriage. Power is the amount of laser energy delivered to the piece being cut. And frequency is the number of laser pulses that the laser fires per inch of travel. Now, we're not just going to leave you to guess these settings. We have a sheet by the laser where you're going to look up the settings specific to the material you're cutting. For example, if you're cutting wood, you're going to look up the wood settings by going to the wood section, and you'll choose your settings based on the thickness of the wood. So for example, if you're cutting a 1/8 inch piece of plywood, you'll see here that your cutting speed is 70, your power is 75, and your frequency is 500. Now, it's important to know the relationship between speed and power. One piece of wood will vary drastically between another piece of wood. So settings that you're used to using may not work all the time. For example, if you're cutting a 1/8 inch piece of wood and you find that your cutting is not going all the way through, you're going to want to know what you need to change. Do you increase the speed or do you decrease the speed? Do you increase the power or do you decrease the power? So let's start with power. Now, power is straightforward, right? The higher the power, the more laser energy you're setting to the piece being cut. So if you want to create a deeper cut, you would increase the power. If you want a lighter cut, you would decrease the power. Same for engraving. Now, speed is the opposite. If you want to cut deeper, you're going to want to slow down the speed. And if you want a lighter cut, then you're going to want to increase the speed. So if you're cutting a piece of wood and it doesn't cut all the way through, well, you've got a couple options here. You can either slow down the speed or you can increase the power. And it's the same thing with engraving. If the piece you're engraving is going too deep, well, you can decrease the power or you can increase the speed. The frequency doesn't change. You'll get higher quality from your engraving if you position the wood so that the grains are traveling in the same direction as your laser carriage. So you want to position the wood so that the grain goes from left to right instead of up and down. And a tip here to save time on your engraving is to always orient your artwork so that it's landscape. Now you can see how this will result in a faster engraving time. Imagine the laser going back and forth scanning, and each time it moves back and forth, it's engraving your part. Now, notice how it has to each time slow down, stop, turn, and then come back as it moves down the part. And in this instance here, it's just not covering much area per scan. Now, if you just orient your part so that it's in a landscape orientation, you're getting a lot more coverage per the move. So in this case, you're looking at a 38-minute engraving time versus a 56-minute engraving time here. Okay, now we get to the most important part of this presentation, and that's safety. The number one rule in operating the laser is that you never operate the laser unattended. There have been cases, not within our makerspace, but in other makerspaces, where I've heard tragic stories where someone starts a laser and decides that they want to go get a sandwich across the street, and they come back to a fire. You want to be around the laser, so if that any problem arises, you want to be there to address it right away. This is how you prevent fires from happening. Even materials that you're used to using can flame up. Sometimes this can be user error. For example, you set the wrong speed and power settings. If you set your speed way too low and your power way too high, you can potentially have a material flame up. Another situation where this can happen is, let's say you're cutting out a circle and you accidentally copied and pasted 10 circles on top of each other. Well, on your drawing you only see one, but the laser will read it as 10 circles. And if it's going over the same area 10 times, that's another instance where you can have a potential flame up. So be careful for these situations and always be attentive so that if they happen, you can be right there to address them. Another important rule is to only cut and engrave approved materials. If the material is not on the approved list, then it doesn't go in the laser. Always make sure the air filter is on when you're cutting. If you forget to turn on the air filter, you will smell the fumes right away. So before hitting go on the laser, you always want to go through a mental checklist, knowing that you have focused the laser and that the air filter is on. When you're vector cutting, that's when you're using the most laser energy. So you want to be careful here and you want to be the most attentive, because if anything is going to go wrong, it's most likely going to happen when you're cutting. Never engrave or cut PVC or vinyl. These release chlorine gas, which is very bad for you, it's very bad for anyone else in the room, and it's corrosive to the machine. And the basic rule here is always know what you're cutting. If you don't know what the material is, don't guess at what it is, and it does not go in the laser. And finally, as you put material in and out of the laser, be careful not to hit the laser head. We've never had a fire in the makerspace, and if you follow all the rules, we shouldn't get a fire. But if it does come up, I want you to be prepared and how to handle it. The lab manager and our lab assistants will always be around, so you'll always have someone to turn to if you have any question on what to do. But it's important to know what to do in case you find yourself alone with the laser and a problem arises. Now, the first thing I'll say is that sometimes you can get a small, short-lived flame that can be moving with the laser. It's like a little candle flame that will follow the laser as it's cutting. Normally, these die off right away. But you want to begin paying attention if the laser is cutting in one area and there's a flame in another area that's not going out. And if the flame doesn't go out, you want to hit the stop button on the laser. This will stop the laser from firing, and in most cases, the flame will extinguish by itself. However, if the flame persists, at this point, you want to yell for the lab manager or any lab assistant to come help you. And then you want to open up the lid. And usually just a little draft of air that goes in will put out the flame, or you can just blow it out if it's a tiny little candle flame. If this does not work, we do have these spray bottles of water that are right next to the laser. You can simply give the flame a few squirts and this will take care of the problem. However, if the flame still persists, then we do have fire extinguisher right by the laser, and in this case we have a smaller fire extinguisher that puts out a clean agent. And if you need to use this, go for this smaller fire extinguisher first, as it's easier to clean up. And if necessary, we also have the bigger regular fire extinguisher. The water bottle and both fire extinguishers are located directly to the left of the laser cutter.